Welcome to the Richie Flow Nutrition Podcast. My name is Cameron Borg. On this episode, I had the pleasure of speaking with Jean-Claude Guimberteau. Jean-Claude is a French surgeon who specialises in endoscopic investigations of the human extracellular matrix, otherwise known as fascia. Over the span of several decades, Jean-Claude has documented thousands of hours of footage of living tissue and the spaces between the tissues. He has observed that the living extracellular matrix is a dynamic and fractal structure capable of absorbing stress and distributing it throughout the entire system in a non-linear manner. His work overlaps that of biotensegrity, systems biology, and non-equilibrium thermodynamics, even extending to ideas of how posture might influence cellular and even genomic processes. Jean-Claude is a brilliant thinker whom I found to be far too humble given the unique nature of the work he has done and continues to do. In our conversation, we discuss how the extracellular matrix works and from what it is made. We delve into the implications of piezoelectricity and charge within the human body and much, much more. I've also started a Substack where I go into my podcast topics in even more depth and offer my thoughts and ideas as well. If you want to support the podcast, Substack is the best way of helping me continue doing this. With all this being said, I hope you enjoy the episode. Jean-Claude, I can't thank you enough for giving me some of your time. Your book that I read a couple of years ago has been one of my top 5 of all time, and I've read a lot of books, so thank you so much. I really appreciate you giving me some time.
Yeah, it's a pleasure for me to make people understand what I have seen, because my experience for me is unique, because it was the first time I was seeing living matter really living.
Yeah.
And I have been surprised by what I have seen, because I was not really prepared to see that. And so I have been surprised by the connective tissue, by the role of connective tissue, which is not only a packaging tissue, but in fact, it's the constitutive tissue, it's our architecture.
Yeah.
This is the first point. And the second point is that cells are not everywhere. So it's not the main, it's one component, but it's not the main component. This is the second point. And inside of each of these 2 main points, concerning the fibrillar network, I have been surprised by the irregularity of this network. This is surprising, because this fibrillar network is supposed to give you the movement. And I was at that time, I am still now, I was very interested to understand how is working the gliding system around the tendon. And, this gliding system is a very efficient system. And I saw that this efficient system was with a totally irregular architecture. So I was obliged to combine irregularity and efficiency, which for a surgeon is really surprising. And the second point is concerning the cells. In my ideas, I thought that, well, it's a very primitive idea, but it's the idea of a surgeon, of a normal medical student. I thought that the cells was almost the same everywhere, with the same disposition in the body. So a sort of bricks everywhere, to make my form. But in fact, not at all. Not at all. There is a real comportment, behavior of cells inside the body. And for me, all the cells are different in shape. So it's surprising to see all this diversity everywhere in my body. at the result, it's my form, which seemed to be very irregular. So, you have to combine these two elements, irregularity and regularity at the finite point.
That's
Do you understand my English?
Yes, no, it's perfect. You said your English wasn't something you practice very much, but it's better than most people who speak English here.
No, because I speak English, but I don't speak English very often.
It's fantastic.
So my vocabulary, at the beginning, my vocabulary is not instantaneous. I have to think to use my vocabulary. So sometimes my way of talking is slow.
Well, you haven't missed a beat so far. I wanted to ask you, when you began filming these surgeries that you were doing and having a look at this extracellular matrix, this space between the cells, all of this stuff that's not cellular, and it comprises of all these different layers that you found where they're actually interconnected. You can't splice them apart. They're all together. What did you expect to find, or what were you looking for when you started filming these? Was it just a curiosity?
Well, when I start, it was to understand how was working the sliding system around the tendon.
Yeah.
But I was not prepared, as said, because in my mind, in the normal teaching way, I had on one side connective tissue, on the other side spare parts, spare organs. The connective tissue was connecting organs with cells, and I am happy because it's conform to the textbooks of medical teaching. So I was completely, it was a totally, how can I say, earthquake for me to discover that. And at the beginning, I thought what it was only impression. And so I decided to share what I have seen with colleagues. And you have two types of colleagues. You have interested colleagues, very few, very few. And you have colleagues not interested at all, because a surgeon is first a technician. So if it's not technical aspect, they are not really very interested. Yeah. So I show these images to some colleagues, and of course, all of them, as I was disturbed by that. And I have tried to find many works concerning connective tissue, but in fact, you have very few works. And you have no works concerning the disposition of the connective tissue in the three-dimensional space, first. And second, the mechanical behavior of the connective tissue during the movement.
Yeah.
There is no works concerning that. So I was obliged to work on my side to try and to find solution to explain what I had seen. And so I began to imagine the way of doing fibers, thanks to my observation inside the body. How is it sliding? How is it dividing, gliding, lengthening in an instant?
Mm-hmm.
This is one of another surprising aspect is that the movement is decided at the last instant. It's not prepared in advance.
It's dynamic and adaptive.
Yeah.
Yeah, yeah.
And it's very close to the quantum physics.
Can you elaborate on that?
I'm sorry, the sound is very bad.
Oh, sorry. Can you elaborate on that aspect? You mentioned quantum physics.
No, but I think that quantum physics are concerned. And I read a lot of books concerning quantum physics, but in fact, they are not adapted for the living. Quantum physics is, how can I say, is accepted for inert system, for theoretical systems, but not for living. It's just a beginning now.
Yeah.
It's just a beginning. But really, it's surprising to see that the fibers are dividing in one way and in one instant.
Mm-hmm.
And you never know when and where. So this is a way of doing quantum physics. But I am a surgeon. I am not a scientist or physicist. So it's difficult for me to have an affirmative answer. But it's my way of thinking.
Mm-hmm. Can we take a moment to try and define? I know there are a lot of terms that get thrown around when we're talking about this space between the cells, I guess you could say. Some people call it the fascia, some the extracellular matrix, some the ground substance. And you mentioned the microvacuolar collagenic absorbing system. Are these all just same words for different? All the same.
It's the same.
Yeah.
All the same. Yes. Yeah. Depend of which medical category you are.
Right.
Or if you are a scientist, a physicist, if you are a medical doctor interest in surgery or interest in histology, if you are a osteopath, well, in fact, it's the world around the cell.
Yeah.
So it's the extracellular matrix. I think it's the best way. And the extracellular matrix has an architecture. And this architecture is a fibrillar work with, of course, different levels in terms of scale. It's not the same scale everywhere, of course. It's not the same system everywhere. It's a system in continuity, but totally adapt with the scale needed. So if you are at the high level, you have cells larger. If you are at the lower level, for example, if you are at the abdominal wall, abdomen, you can find large fibers. But if you are at the level around the tendon, for example, you have very tiny fibers, you know? And so if you have an intercrossing of fibers in the three-dimensional space, at the level of the tendon, you find small microvolumes, microvacuums, and at the level of the abdomen, you have bigger, of course.
Yeah. And the fractal nature of these microvacuoles, as you call them, allow the system to sort of adapt dynamically given what stresses they're under. So the whole system can sort of act as one together, and all the movements can be compensated at the right level.
Absolutely. It's an absorbing system.
Yep.
So it's moving fibers around the tendon, for example. When the mechanical constraint appear, the fibers give an instantaneous response with lengthening and dividing and so on.
Yeah.
But at a different scale, the constraint is beginning to be absorbed. And at another scale, it's again absorbed. And at the level of the skin, for example, the mechanical constraint totally, how can I say, efficient at the level of the tendon is totally absorbed at the level of the skin. It's why you can move a finger without moving the skin, you know?
Yeah.
So it's a sort of absorbing system.
And this is very reminiscent of a tensegrity system where when you move one part of the system, everything else sort of adapts in various degrees to adjust.
Yeah. Absolutely. It's why a long time ago now, maybe 15 or maybe at least 15 years, I have been in contact with Stephen Levin. Stephen Levin is a American surgeon, and he's an orthopedic surgeon, and he found that our way of he found that the body could be compared to a tensegrity system, and it was an excellent idea. And I think that my way of thinking is totally fitting well with tensegrity, biotensegrity.
Yeah.
And now I was in a congress in Lyon next week, and I had the impression that the biotensegrity concept was a little bit moving, and now the irregularity of the basic system seemed to be more accepted. Because at the beginning with Stephen Levin, we were not really totally in coherence because the biotensegrity system is based on regularity. It's a regular polyhedron, icosahedron, and on my way, I found only irregularity. So this was one of the main difficulty for me. It's that in biotensegrity, there is no irregularity. And in biotensegrity, there is no movement of the frame. But now, listening one of my colleagues speaking last week, I think that they have a little bit moved to this mechanical behavior. So in the next steps, I think we will be completely fitting well.
Yeah, it seems, and I've read some of Steve Levine's work, and it seems to mesh perfectly well with what you're talking about. You're talking about this system, this whole system that acts as a whole. You know, you can't just affect one part but not the other. They're all connected to some degree or another.
Absolutely, well, yes. All the parts in the body are connected.
Yeah.
There is no free plane at all. You can find free plane, but it's completely explain and adapt. But the main basic system is a fibrillar network. Yeah.
And you mentioned irregularity a lot, and this is something that comes up a lot in the book, this idea that you're getting these very irregular shapes, and perhaps the irregularity allows the system to be more responsive to the stimulus that are coming in.
Yes.
And it seems that this chaos order from chaos idea sort of comes about with this idea of negentropy and systems utilizing chaos and entropy to self-organize and adapt. Is this something that that you also thought about from a thermodynamic point of view, that complex systems use entropy in order to self-organize and adapt?
Yes, yes. I have to mention that I record 12 conferences on a platform. The platform is called InVivox, and I am talking about these problems.
Mm-hmm.
Of course, when you are observing this fibular network, first you are questioned by, we talk about that, irregularity. Why irregularity?
Yeah.
Why? This is the problem. Why? Because everything in the nature is irregular.
Mm-hmm.
Everything. So why? So you can have the Earth's polarity, you can have the gravity, the force of gravitation,
Mm-hmm.
and there is also another explanation. I don't remember really. I think it's a Japanese, Kobayashi and Matsakwa, I think. Maybe 20 years ago, they had a Nobel Prize for that. And they say, no, the irregularity is coming from the beginning, just after the Big Bang. Before the Big Bang, we had regularity, but no matter. After the Big Bang, we have matter, and progressively we have apparition of irregularity. So they say that irregularity is original. We can't be regular.
Mm-hmm.
You understand what I said?
Yeah, it seems that nature prioritizes irregularity and to some extent chaos because it allows it a greater response to various perturbations. It allows it to be more robust. Yeah.
Yes, yeah. I agree with that totally.
Yeah.
Yes.
Yeah, and there's no reason for the fibulary system to be any different because it allows us to do things that our bodies have never been exposed to before, but they adapt to it anyway.
Yes, absolutely.
Yeah.
And you can have, because it's irregular.
Yes. That's exactly it. Yeah.
But it's difficult to first to understand and to accept that the best way to give the best response is irregularity. It's difficult for a human.
Yeah, no, it's difficult for us to perceive that that's the best way because we like everything so regular. I mean, even our houses are all regular shapes, 90-degree angles everywhere, but
absolutely,
nature doesn't work like that. Yeah.
No. It's why I say we have a human way of thinking,
mm-hmm.
but it's not the nature way of doing.
Mm-hmm.
It's different. And we have to accept that. Now, during the last century, it was the contrary, because humans wanted to control nature.
Mm-hmm.
It's at the end of the 19th century, in England, in France, in Germany, it was the mechanical period. And the human wanted to control everywhere in the nature. But 1 century after, we have to accept that we can't control the nature. We can't because nature has different rules to do, and humans have to accept and to accept and to do with nature. So it's another period of thinking. And of course, you can find inside our body, your body, my body, we can find easily with a simple observation that nature has different rules compared to the human. That's an evidence. And we have to accept that.
Yeah, I know. I couldn't agree more. And without that way of thinking, you would have never made the discoveries that you have and come to the conclusions that you have. And one of the ideas that comes through in the book is this idea of non-linearity. And there are quite a few comments by bodyworking practitioners, so osteopaths and so forth, who work with people with restoring their body. And one of the ideas that comes forward in their comments of your work is that they now realize that you no longer need to apply so much force to achieve the result that you want to get with a person, with a restoring someone's movement, because it's a non-linear system. It's not a 1-to-1 ratio. The amount of pressure you apply to a muscle and so forth, you can work much more gently and precisely and achieve the same result. And I think that's something that's really important to underscore, is this idea of non-linearity.
Yeah, absolutely. It's totally non-linear.
Yeah.
It's totally non-linear. So you have irregularity, non-linearity, chaotic aspect, and certainly it's a very, how can I say? It's very, in English, it's, concerning energy, it's very economical. No, it's not. Well.
Yeah.
You save energy.
It's maximally efficient.
It's maximally. And you can use the works of Ilya Prigogine.
Well, I was going to ask you about Ilya Prigogine. Yeah.
Yeah.
It's a perfect analogy.
You can explain that thanks to Ilya Prigogine dissipative system.
Yes.
Yes, it's a negantropy.
Yeah.
You save energy to make another way of doing. But there is no total entropy.
Yeah.
He called that dissipative system. And so you have a buckle, you have a circle making life.
Yeah.
Of course, at the end, there is a total entropy at the end. But meanwhile, you can make life.
Yes.
So you can combine all these elements. You can combine dissipative system, non-linear system, chaotic system. So, yes, I have tried to introduce all these ideas. Of course, I am not certainly right in all the fields, certainly, but we have to open our minds concerning anatomy. Otherwise, we stay teaching Vesselian anatomy as it's taught for at least 3 or 4 centuries.
Yeah.
Always the same, always the same, always the same. But frankly speaking, now with the technology, it's impossible to say, well, we close our eyes.
Yeah.
We are swimming in the obscurantism and life is going without problem. No, we have to observe, to think, to how can I say, to open windows.
Mm-hmm.
Yeah.
So what are the main constituents of this fibrillary network? I mean, I'm sure collagen protein is probably one of the main ones.
Yes, 1 and 3
Yeah, one
seem
and
to
three.
be the main. But if you analyze, for example, at the level of the abdomen, and if you analyze the same fibrillar work, but at the level of the tendon, it's not the same percentage. They change. So there is a lot of work to do to analyze all these collagen 1, collagen 3, collagen 6, glycoaminoglycan,
Yes.
lipids inside what I have called microvacuole, but in fact it's not empty. It's filled of liquids,
Yes.
of fluids, and these fluids are generally colloids. Colloids. You
Yep.
understand?
Yep.
Okay. So colloids. So a lot of work has to be done. It's not my job to do that, but I think for the next and the future generation, there is a work to understand why is it so why a lot of diversity in the percentage. I think it's certainly concerned by the efficiency, efficiency.
Mm-hmm. Are you aware of the work of Gerald Pollack, whose work
Yeah,
on? Yeah.
yes.
I
It's very
spoke to
interesting.
I spoke to Gerald a couple of days ago, and it seems like you two need to get together and you work on some stuff together, because I think you and him have found exactly the same thing. But you have amazing footage of these gels. I mean, the fibrillary network is a gel, and I think this is this gelled water he's talking about.
Yeah, sure. Yes. I met him, I think, in Washington 7 years ago, I think.
Mm-hmm.
And, yes. Well, in my world of thinking, I need to, Stephen Levin is very important.
Yeah.
Gerald Pollack is also very important. And for contemporary, yes. And there is also, I don't remember, it's an American concerning cells. It's, sorry.
That's
I
okay.
don't.
Yes. Yeah. I think what Gerald Pollack is also talking about with aging is a loss of this structured water, this easy water. And it seems like the fibrillary network also breaks down as we age, and it loses
Yes.
its adaptability. And it seems like that's perfectly matched with what Gerald Pollack is saying with
Yeah,
this loss of EZ.
absolutely.
Yeah.
And when we are talking about biotensegrity, for me, biotensegrity is the only system able to explain the growing. When you are a little baby,
Yeah, right.
you are around 4 kilos of living matter, and during 20 years, you are going to fight against gravity to grow. But when you are 20, you are at the top of your size, for example, and so you have been the winner against gravity. But around 20, gravity takes its revenge. And little by little, inside of our body, all the elements of the architecture, I mean, collagen and fluids, are altered, are disturbed. And I think it's programmed. But little by little, gravity takes its revenge. And gently, during times, we are collapsing. Yes.
Mhm.
And of course, I agree with Pollack. Yeah.
Yeah, that's so fascinating. Before you also mentioned glycosaminoglycans, and my understanding of these proteins is that they can store quite a lot of negative charge.
Yeah.
And I know, well, I think I remember from the book that James Oshman was involved as well.
James.
And
Oh, yes.
and
James
James,
Oshman.
he
Yes.
talks about earthing, this idea of when you put your bare feet on the ground, you're able to basically take up free electrons from the earth, and they essentially get stored in these glycoaminoglycans as a repository of negative charge. Is this something that you've also looked into?
No.
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 Okay.
No. 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 I, in my way of trying to give information, I had only one rule: only talking about what you have observed.
Right.
So I am a surgeon. So I am trained to observe inside a body.
Mm-hmm.
I am a surgeon with an endoscope. So I can observe inside the body with magnification.
Mm-hmm.
So I saw many things. I try to explain with all other science, like physics, biochemistry, and so on. But all the all this knowledge is not mine. All this knowledge is from many scientists and physicists.
Yeah.
So I try to understand first. It's not so easy sometimes, but it's not the fruit of my work. So I can talk about, but it's difficult for me to say he's right or she's right,
Mm-hmm.
or she's wrong or he's wrong, because I have not all the elements to give my opinion.
Yeah.
I am not a scientist. I am only a surgeon and an observer.
Well, I think I would consider you a scientist for sure, given the amount of work that you've been doing over the last few decades. One thing I wanted to ask you about was this idea of piezoelectricity, which, in my understanding, bones and muscle exhibit piezoelectric activity. Is this true?
Yes, certainly. But as I said, I can't observe that.
Mm.
If you want to have an idea when you are a surgeon of the electricity inside your patient, you look to the screen of the ECG, and looking that,
Yeah.
you have the proof that there is electricity inside your patient,
Mm-hmm.
but you can't see it.
But we know that bones and muscles have these piezoelectric properties. So when they are moved, they are generating the movement of electrons throughout the body.
Oh, yes.
Yeah.
Yes.
But what that means is still up for debate.
Yes, but I can't talk about, because
Yeah.
I can't see it. But of course, I agree when some colleagues are talking about piezoelectricity. I agree. Yes, we can't exclude electricity inside the body, of course.
Mm-hmm. One of the quotes from the book that I thought really resonated with me was, you say the study of the cell has monopolized scientific attention. And this is something that you alluded to in the beginning, is there's so much focus on how cells work, but at the end of the day, the cells are part of a system that is intimately connected with the extracellular matrix, and the extracellular matrix is just as important as the cells that it's connected to. And there is a part, particularly towards the end of the book, where you emphasize that this extracellular matrix is intimately connected with the cytoskeleton, and the cytoskeleton of the cell is intimately connected with gene regulation. So it seems that the way that our extracellular matrix is resting or moving is impacting the genetic expression in the cell.
Well, it's an hypothesis. What I can prove
Mm-hmm.
is the total continuity between the cells and the fibrillar system. There is no, how can I say, virtual space between the both.
Yeah.
Cells and fibrillar network, the frame, are totally in fusion. It's a total fusion.
Yeah.
There is no separation. This is the first point. The second point is I can say and I can prove that when you move extracellular fibrillar network, you can change the shape of the cells.
Yes. Yeah.
I can prove it. And I know that when you are moving the cells, you are moving the cytoplasm. I know that.
Yeah.
Because you have inside the cytoplasm, you have a sort of mechanical fibrillar system also. And it seemed to be the same inside the nucleus.
Mm.
So you can say, well, there is a total continuity between the fibers I have seen and the nucleus. And inside the nucleus, you have DNA and so on. So there is a total continuity. It's why I say when you are moving the fibrillar network with a very simple massage, for example, you have a mechanical role on the cells. After you can give the hypothesis, maybe this mechanical role on the cells has a mechanical role on the production, the protein production.
Yeah.
But I can prove it. It's not my job.
But it makes sense. I mean, if you follow that logic, that structure and function are always so intimately related that, of course, if you're changing the structure of the cytoplasm and the cytoskeleton, of course, you're changing the function of the cell. You know, that's undeniable.
Yeah, you can imagine that. But
exactly, yeah.
But you have to prove it.
The specifics are yet to be worked out, but you know, I mean, like you said, even a simple massage. I mean, everyone feels better after gentle palpation of the body, and I think this is part of the reason why body working, sort of modalities seem to work so well, not only for physical, but also for the mental side of things as well. It seems to have an impact.
Yeah.
Mm-hmm.
You can say that.
Yeah.
And nobody can say the contrary.
Yes.
But if you want to be completely sure, we have little by little to try to prove it.
Yeah.
With biochemistry, biophysics, and so on. So there is a lot, as I said, a lot of work to do to change our way of thinking human anatomy. And when I'm talking about human anatomy, I can say also animals anatomy. Because
Absolutely.
it's the same. It's the same, human is not completely different of a cat, of a dog, no, we are globally the same way of functioning.
And in your investigations, have you noticed any, substantial inter-individual differences between this fibrillar network, or is it basically the same no matter who you're looking at?
It's basically the same.
Right.
But I am sure that for me, looking at, it's basically the same.
Yeah.
But I am sure that it's different because you have not the same shape as I have. So your network is different of my network.
Yeah.
True. I can say that when we are getting older, the microvolumes are bigger.
Right.
Bigger. And you have less fibers.
Mm-hmm. So presumably that translates to less adaptability, less ability to deal with various fluctuations in the system.
Yeah. Yes, you have a lot of fluctuation in the system and variation concerning age. Sure. Concerning age, and you have changing fluctuation concerning inflammatory disease, concerning scarring tissue, edema, hematoma. So you have change. Yes, you can change. And some are able to recover globally, not at all, but globally. And some change are totally non-reversible as scarring tissue. Scarring tissue is not reversible. Totally, I mean.
Yeah.
When you have a scar, the harmonious system of the mechanical behavior is totally destroyed forever.
Yeah. And you mentioned edema before. I see a lot of people in my job with quite uncontrolled edema. How does your view of this shape? What you feel edema is and how it can be perhaps addressed.
Sorry, I don't understand what you mean.
I see a lot of people with edema.
Yes.
And from your perspective, what do you think might be contributing to the collection of fluid in this space?
Well, I think when you have edema, it's because there is certainly something which slow down the flow inside the extracellular system. So all the microvacuoles are swollen. You understand what I'm saying? Because
yeah, absolutely.
Are swollen, are bigger. So skin is dense. Movement is reduced because the fiber can't move easily because the volume inside the microvacuoles are under high pressure. So because there is something which slow down the flow, and for example, you can have radiotherapy, for example, which is destroying all the fibrillar system, and so the flow is not able to cross this area. So there is a slowdown, and the flow is obliged to use different ways around the scarring tissue after radiotherapy. And so, of course, you have, I don't know the word in English, but of course you have a swelling of the edema inside the microvacuole.
And I presume this is sort of what's happening in inflammation. Like if you hurt your ankle or something and it swells up, this is that sort of collection of fluid to sort of protect the site and also to help dissipate energy. Sort of what we were talking about before.
Certainly. Well, for me, it's easier to say it's because there is something which make not able the flow. But concerning you are right. Concerning, for example, inflammatory disease at one point, why is it under tension and why is it swelling? It's difficult to understand that because it's probably localized. It's localized.
Yeah.
and there is nothing around this inflammatory reason explaining why you have edema. Well, we have to think about that. But I have no explanation.
Yeah. I don't think anyone does. If you have one, you might win a Nobel. So, if anyone can come up with the exact reason, I'm sure they'll be in for a Nobel.
Yes. Well, it's very interesting what you say, because in medicine we have a lot of cases of this kind of cases. We know concerning edema, inflammation, scarring tissue, but we have no real explanation. How is it doing? We know that inflammation is with vasodilatation of vessels, of fluids. But how? How is it working? How is it healing? We don't know that.
Yeah. I think the best explanations that I've seen have been looking at it from a thermodynamic point of view, where it is this generation of chaos in order to dissipate energy, in order to reinstate this non-equilibrium thermodynamic state, which makes the most sense to me, which ties in exactly what you're talking about with this idea of efficiency and chaos going hand in hand.
Yes. Yeah, I agree with you. We agree together. But, in the medical world, few people are agreeing with this kind of thinking.
I know.
So, we can talk, but if we want to influence our other colleague, we have to wait centuries and centuries, I think.
I know it's unfortunate, but hopefully we can get to the individual first, and we don't have to wait for the doctors. The people who are hearing this can understand that we're a whole system, and the body doesn't make any mistakes. It knows what it's doing. We just have to sort of give it the right tools and environment to get back to this non-equilibrium thermodynamic state, and that's what health is. The ability to balance in the middle of order and chaos.
Yeah, but what you say is very interesting for me. It's certainly very interesting for few people around you and me, but that's all.
Yeah.
That's all.
Hopefully it's growing.
Yes. I think your generation will see the result of our discussion, our talk in the next decade. Young generation will be more able to understand this way of thinking. Yes. Yeah, because we are not in a total now. We know that things are not only rational. Inside the rationalism, there is a part of non-rationalism.
Absolutely.
This is a new way of thinking. And this is very interesting for the future.
So how does your work sort of change the way you think about the impact of exercise on health and longevity? Clearly, there is a link between people who are moving all the time, walking around, doing light activities like gardening and Tai Chi and things like that. It seems to me as though what that's doing is preserving this fibrillary network over a long period of time. Is that something that you think about?
Yes, it could be helpful. I am not sure of the total efficiency because you have people who died around 100 years without doing any physical exercise. So I think there is a personal, genetic predisposition first, but of course, the training is good.
Yeah.
So we have to train it. Yes, I agree with that. But it's not the only way to survive until 100 years old.
Mm-hmm. And how does this shape the way you think about manual therapy? So things like massage, like you mentioned before, is this something that you feel would be a good thing for most people to have, on some sort of regular basis?
Yeah, why not? No. When I say massage, it's when you have some pain in some place,
Mm-hmm.
and you can, thanks to the osteopathy, you can improve. You can improve, but it's a how can I say? It's a therapeutic massage. It's not a massage for the comfort. It's the massage in order to improve the wealth of the people.
Yeah. Yeah.
But concerning the comfort, maybe, but never mind, never mind. It's very good to say to people, try to improve your way of doing by making exercise, making fitness. I think it's good. It's good.
Yeah.
Nevertheless, it's good.
And how about the growing interest in red light therapy? Have you heard anything about that?
No, absolutely.
No. Okay. Yeah, that might be. I mean, I wonder if light impacts the way that the fibrillary network sort of aligns and moves, because all of your videos would have been done, in a surgery room where there's no natural light. It would be very interesting to see if different types of light would shape the fibrillary network, but that's something that might have to come later.
Yeah, for your generation.
So,
yes.
Where is your work going now? What are you working on at the moment, or what are you interested in exploring?
I know. I record, as I said, I record on a platform. I record 12 conferences.
Mm-hmm.
It's 12 conferences. Each one is around 12, 15 minutes. So it's short, of different topics. I have finished a book, a new book, which will be certainly published at the end of the year. It's a book concerning my works, my observation, my way of thinking, but also concerning the influence on philosophy. So I try to speak about a little bit of philosophy.
That's philosophy is sorely needed in science at the moment. I think we need more philosophers in the scientific field to help us understand, because, like you said, nature is not rational, and the way we think is too rational. We need to be more philosophical with the way that we approach these concepts.
Yes, I think so. But philosophy is sometimes philosophy is very irrational.
Yeah, absolutely. Yeah, it can help us sort of look at things from a different angle.
Yes, it's an opening.
Yeah, exactly.
Yes, with philosophy, you can open the field, I say, the field of possibilities, which can be different of the field opened only by rationalism. You have to open your mind and to see, maybe I am wrong, maybe I am not completely right. I have to modify my way of thinking, because the evidence is that, for example, irregularity can explain efficiency.
Yep, absolutely.
1 century ago, I was not able to say that.
Yes.
Because at that time, efficiency is regularity only. Now we say no.
Yeah, and we can prove it too. And something that's this has been the best book that I could possibly recommend. So I'm going to make sure I leave links to your book, because not only is it a book, it's got all your videos, lots of clips of videos that explain what you're talking about. And it is, it's interactive in that way, and it is beyond valuable to help you understand how the body works and why this extracellular matrix is as important as the cellular component of the body. And we've basically completely forgotten about that in biology, which is unacceptable.
Yeah, all right. Okay.
Yeah. So I just wanted to thank you so much for giving me some of your time. I've enjoyed this conversation so much, I can barely put it into words. And I can't wait to share your work, and hopefully people read this book before the new one comes out. I'll be definitely pre-ordering the new one.
Okay, thank you very much. It's a pleasure for me.
Thank you so much for listening, everyone. I hope you enjoyed the conversation as much as I did. If you want to learn more about Jean-Claude, please consider supporting him by checking out his brilliant book, The Architecture of the Living Human Fascia, which I've linked below. He also has a great documentary about his findings called Strolling Under the Skin, which I've also linked below. Please feel free to subscribe to the podcast. It really helps me grow the channel and get more incredible guests to speak with. The bigger the channel grows, the more seriously I can approach more amazing guests to have on. I also have a Substack that I use to go way deeper into these podcast topics and offer my thoughts and ideas. This is the best way to keep on track with the work while also supporting the podcast at the same time. I've left links below where you can follow me on social media, where I share a lot of health-related information. Thanks again for listening, everyone. Take care.